Our world map is missing entire continents hidden beneath the waves. During the last ice age, shorelines were miles out from where they are today. Those now submerged plains hold the true cradles of civilization, a secret locked away by rising seas. We are about to uncover how geological and archaeological evidence reveals these lost birthplaces, from the sunken continent of Sundaland to the flooded oasis of the Persian Gulf. By the end, you will understand a completely new origin story for human society. What happened to the advanced cultures that flourished on these coastal plains? Where is the proof that our first cities now lie underwater? How much of our past is still waiting to be discovered on the ocean floor? What does it mean to find a world we thought was lost forever? 26,000 years ago, our planet wore a completely different face. The air was colder, the climate drier, and colossal walls of ice sprawled across continents. These were not mere glaciers, but ice sheets so immense they locked away a staggering volume of the world's water. Think of the entire planet tilting on a scale, with the weight of all that frozen water pulling sea levels down, not by inches, but by over 120 meters. That is like removing a 40-story building worth of ocean from every coastline on Earth. The result was a geographical revolution. Where today we have rolling waves and deep blue abysses, there were instead vast exposed plains. Continental shelves that had been submerged for eons suddenly became dry land, stretching for hundreds of miles out from the present shores. This was the world of the last glacial maximum. And these newborn territories were far from empty. They were vibrant, living landscapes. Great rivers snaked across these plains, fed by meltwater from the distant ice. They carved valleys and filled enormous lakes, around which lush grasslands and forests thrived. This was a paradise for wildlife, from massive herds of mammoths and giant deer to the predators that followed them. And where the game went, humans followed. This radically altered map did not just create new land, it connected the world. For instance, the islands of Indonesia, Java, and Borneo were no longer islands at all. They were all part of a single colossal peninsula known as Sunda, a super island firmly attached to mainland Asia. You could have walked from modern-day Vietnam to Bali without ever getting your feet wet. Similar land bridges appeared everywhere, from the vast plain linking Britain to Europe to the legendary Bering Land Bridge that served as a gateway to the Americas. This was the stage upon which humanity's greatest migrations and earliest settlements were set. It was on these now vanished coastal plains, with their abundant resources and connected geography, that the first seeds of complex society were likely sown. So the question is not if people lived there, but what they built. What traces of their world remain, waiting for us on the dark ocean floor? These submerged continental margins hold the key to understanding our ancestors' journey. Think of a continent not as ending at the beach, but as extending far out underwater on a gentle, sloping plain. This is the continental shelf, the true outer edge of the landmass. During the Ice Age, this was not a hidden underwater world, but a sun-drenched frontier. As the oceans receded, these shelves emerged as vast, open plains, often more welcoming than the harsh, icy interiors of the continents. They were not barren, but incredibly fertile. Early modern humans, already skilled at gathering food from the seashore, would have found these new coasts irresistible. They did not see a dead end at the water's edge, but a highway. This is the core of the coastal migration theory. Instead of a slow, arduous trek through difficult inland terrain, these resourceful people moved with remarkable speed along these exposed shelves. Why would they struggle through dense forests or cross mountain ranges when they could follow a coastline that provided everything they needed? These fertile corridors offered a smorgasbord of resources. On one side, the ocean provided a reliable, abundant supply of shellfish, fish, and seaweed. On the other, the plains teemed with game and edible plants. The most valuable real estate were the estuaries, places where rivers met the sea. These were hotspots of life, with rich mangrove forests and lagoons bursting with food, creating perfect locations for semi-permanent settlements. This model completely overturns the old textbook image of humans moving solely overland. It suggests that the fastest and most successful migrations happened along the edges of the world, on land that is now completely lost to the sea. And that is the great dilemma for archaeologists. The very evidence that would prove this theory, the campsites, the shell middens, the tools dropped along those ancient trails, all of it now lies at the bottom of the ocean. This creates a massive, silent gap in our story, a sunken chapter of human prehistory. What incredible discoveries are waiting for us, not buried in desert sands, but hidden beneath the shifting sediments of the continental shelf. One of these lost worlds was a continent in its own right, a sprawling subcontinent known as Sundaland. This was not a mere land bridge but a colossal territory, a continuous plain roughly the size of India that fused the Malay Peninsula with the great islands of Borneo, Java, and Sumatra. This was a landscape of incredible diversity, far from a monotonous flatland. Imagine a vast, sun-drenched expanse crisscrossed by powerful river systems, their waters flowing from distant, ice-capped mountains. These rivers fed enormous freshwater lakes, creating lush oases and supporting rich grasslands and forests. This was a fertile paradise, a world teeming with life and opportunity. The archaeological clues we find in the surrounding highlands, the areas that remained above water, are tantalizing. We find evidence of sophisticated stone tools and early, experimental interactions with plants that suggest the people of Sunderland were not simple nomads. They were advanced foragers, potentially on the cusp of a new way of life, developing a deep understanding of their environment. Then the world changed. As the great ice sheets melted, the oceans began their relentless rise. For the people living on the plains of Sunderland, this was not a slow, distant news story. It was a catastrophic, generation-spanning event. The waters would have crept inland year after year, swallowing their ancestral hunting grounds, flooding their river valleys, and submerging their sacred sites. Their entire world was slowly, inexorably being erased from the map. This was not a simple relocation, it was a great diaspora. Communities were fractured, and entire populations were forced to flee. They carried with them everything they had, their most vital possessions, their knowledge of the land, their languages, their technologies, and their stories. They migrated to the higher ground that we now know as mainland Southeast Asia, or they took to boats and island hopped into the vastness of the Pacific. The sinking of Sunderland did not just drown a land, it scattered its people, and in doing so, it seeded the cultures of an entire hemisphere. The legacy of this drowned continent is not just silt and sediment on the ocean floor. It is written in the genes of modern populations across Southeast Asia, and it echoes in the flood myths found in countless cultures, stories of a lost world consumed by the sea. This forces us to ask a profound question. How much of what we consider to be our ancient history actually began in a world that is now completely invisible to us, a world we can only access through the faint echoes it left behind? Another such lost paradise lies beneath the turquoise waters of the Persian Gulf. This was not always a saltwater sea, but during the height of the Ice Age, it was a vast, sheltered basin, a lush river valley shielded from the harsh deserts. 4 major river systems, including the ancestors of the Tigris and Euphrates, converged here, feeding a sprawling network of freshwater lakes and marshes. This was the Gulf Oasis, a verdant refuge of incredible fertility in an otherwise dry world. For human populations struggling to survive in the arid lands of Arabia and Persia, this valley would have been nothing short of a promised land. It offered a consistent, abundant supply of water, fish, waterfowl, and lush vegetation, creating an environment where groups could settle and flourish for generations. They were not merely surviving, they were thriving, developing a deep, intimate knowledge of the plants and animals around them. It was in this stable, resource-rich sanctuary that the first experiments with cultivation and animal management may have truly begun. Then, around 8,000 years ago, the ocean found its way in. The rising waters of the Indian Ocean finally pushed through the narrow Strait of Hormuz. What happened next was not a gentle, creeping flood. It was a catastrophic invasion of saltwater. The basin filled with the sea at a rate that would have been terrifyingly visible within a single human lifetime. The freshwater lakes were poisoned, the marshlands drowned, the entire ecosystem utterly destroyed. The inhabitants of this paradise had no choice but to abandon their home, fleeing in a mass exodus to the only safe ground, the river valleys to the north that we now call Mesopotamia. This was not a planned migration, it was a desperate retreat. Suddenly, these refugee populations were concentrated into a much smaller area, bringing with them their accumulated knowledge, their social structures, and their shared trauma of a lost world. This forced collaboration and pooling of skills in a new, challenging environment may have been the very catalyst that sparked the Ubaid culture, the direct predecessor to the Sumerians. The Gulf Oasis hypothesis presents a stunning idea that the world's first farmers and the builders of the earliest cities were not pioneers discovering something new, but survivors desperately trying to rebuild a world they had already known, a world that now lies silent and forgotten beneath the waves. The ghost of Doggerland haunts the cold, grey waters between Britain and the Netherlands. This was no simple land bridge, but a vast, inhabited heartland, a territory larger than many modern countries. For thousands of years, Mesolithic hunter-gatherers thrived in this diverse landscape of rolling hills, forested valleys, and mighty rivers that flowed into a great central lake. They tracked deer through woodlands and fished in waters that are now miles out to sea. For a long time, this was just a theory, a lost world inferred from old river channels mapped on the seafloor. Then the evidence surfaced, literally. Fishing trawlers began dredging up more than just fish. They pulled up ancient, worked flint tools, the bones of mammoths and aurochs, and even lumps of peat containing the remains of campfires. These were not scattered fragments, but tangible proof of a lived-in world, a place where people made tools, cooked meals, and told stories under the stars, all on ground that is now deep underwater. The end of this world came in 2 brutal stages. First, the slow, inexorable rise of the sea, swallowing the low-lying plains over centuries, forcing communities to retreat further and further inland. Then, around 6,200 years before the Common Era, a final, devastating blow. A massive underwater landslide off the coast of Norway, known as the Storegga Slide, triggered a colossal tsunami that roared across the remaining Doggerland plains. Imagine a wall of water sweeping away the last vestiges of that inhabited landscape in a single, catastrophic day. For the people living there, it was an apocalypse. This was not a slow migration, but a desperate, forced exodus. Survivors fled with nothing but their lives and their knowledge, pouring into the higher lands of Britain and the European continent. This sudden compression of populations had a profound effect. It forced different groups into closer contact, intensifying social interactions, trade, and competition for resources in these new, crowded territories. This cultural pressure cooker, born from a drowned land, may well have been a key ingredient in the social transformations that later gave rise to Neolithic Europe. Doggerland stands as a stark European testament to a universal truth that our history is deeply and irrevocably tied to the climate. Its story is a powerful reminder that the maps we hold as permanent are merely a snapshot in time, and that the next chapter of human history may yet be written on shores that are still, for now, above the waves. Far to the north, another lost continent held the key to populating an entire hemisphere. The land bridge of Beringia was not a narrow, precarious path, but a sprawling subcontinent, a wind-swept plain nearly 1,000 miles wide connecting Siberia to Alaska. This was not a barren, icy wasteland, but a vast, unglaciated refuge known as the Beringian steppe, a grassy ecosystem that supported an incredible array of life, from woolly mammoths and steppe bison to the first human explorers who tracked them. For thousands of years, this land was a stable home, a place where generations lived and adapted, completely isolated from the rest of the world by colossal ice sheets to the east and south. The traditional story tells of these people waiting for an inland corridor to open between the great ice sheets covering Canada, a narrow passageway that finally allowed them to pour into the continents below. But a profound problem haunts this theory. Archaeological evidence from sites far to the south, like Monte Verde in Chile, suggests humans were already living there before this inland corridor was fully open. So how did they get there? The answer may lie not on land, but along a forgotten coastline. A new hypothesis known as the Kelp Highway proposes a radical alternative. Imagine these resourceful people not struggling through a treacherous ice-bound interior, but skillfully navigating a rich coastal world. As the glaciers retreated, they exposed a chain of islands and fjords along the Pacific coast of Alaska and British Columbia. This was not a barren shore, but a superhighway of abundance fringed by dense kelp forests. These underwater jungles are among the most productive ecosystems on Earth, supporting a smorgasbord of life from fish and seals to crabs and seabirds. The coastal route would have been ice-free and packed with resources, allowing for a much faster, safer migration southward. The journey would have been a leapfrogging motion, from one resource-rich bay to the next, with the ocean providing a constant, reliable food source. This theory elegantly solves the mystery of how people reached the southern tips of the Americas so quickly. Yet, it presents an almost insurmountable challenge for archaeologists. Every single camp, every shell midden, every stone tool left along that ancient Pacific shoreline now lies submerged, buried under hundreds of feet of water and millennia of sediment. The entire material record of this epic coastal voyage is missing, hidden on the drowned continental shelf. This transforms the quest to understand the peopling of the Americas into a marine archaeological puzzle. The true story of the first Americans is not carved into mountain passes, but is waiting, silently preserved on the dark ocean floor, a testament to a journey made possible by a world that vanished beneath the waves. The journey to Australia stands as one of humanity's most epic voyages. Even at the lowest sea levels, reaching this continent required crossing open water, a daring feat that marks these people as some of the world's first true mariners. They did not find scattered islands, but a single, massive continent known as Sahul, a unified landmass connecting what we now call Australia, New Guinea, and Tasmania. This was their new world. The first point of contact for these ancient explorers would have been the coastline, the outer edge of the vast Sahul shelf. These shores were not barren, but a paradise of abundance. Imagine arriving at a coast fringed with mangrove forests, teeming with fish and shellfish, with fertile plains stretching into the interior. It was along these very beaches and river mouths that the first settlements would have been established, the logical starting points for a new life in a new land. But these founding sites hold the key to a profound mystery. When the seas rose, they did more than just separate Tasmania and New Guinea from the mainland. They drowned the entire archaeological record of this initial colonization, the very campsites, tools, and burial grounds that would tell us how these first Australians lived, adapted, and spread across the continent now lie under tens of meters of water and sediment. This creates a massive, silent gap at the very beginning of Australia's human story. Yet, the memory of this lost world may not be entirely gone. Rich and detailed Aboriginal oral traditions from various coastal groups speak of lands that once existed where there is now only sea. These are not vague legends, but specific stories that describe familiar geographic features, river courses, and ancestral events connected to territories now submerged. They may very well be direct cultural memories passed down through hundreds of generations, preserving the knowledge of a world that was slowly taken by the waves. The story of Sahul is a powerful testament to a global truth. From the North Sea to the Persian Gulf, from Southeast Asia to the Americas, the rising oceans at the end of the Ice Age did not just change our maps. They erased the very landscapes where humanity took some of its most decisive steps, concealing the birthplaces of civilizations beneath a blanket of blue. Our quest to understand our deepest past is no longer just a dig into the earth, but a voyage into the abyss. Finding these drowned civilizations is a monumental technical challenge. The field of underwater archaeology operates in a realm of crushing pressures, near total darkness and relentless decay. On land, an archaeologist can walk a site, see the lay of the land, and carefully excavate with simple tools. But to explore a submerged settlement, you first have to find it, buried under countless tons of water and layers of seabed sediment. This is not a job for scuba divers with trowels. It requires a floating arsenal of advanced technology. Side-scan sonar paints an acoustic picture of the seafloor, revealing unnatural shapes and patterns. Multi-beam bathymetry creates stunningly detailed three-dimensional maps of the underwater landscape, showing the ghostly outlines of ancient river channels and lakes. And when a promising target is located, remotely operated vehicles, or ROVs, are sent down as robotic eyes and hands, capable of filming and retrieving artifacts from depths no human could survive. But even with these tools, the evidence itself is fighting against time. Salt water is a brutal environment. It quickly devours organic materials, the wooden posts of a house, the bone tools of a craftsman, the woven baskets of a family, even the skeletons of the people themselves, all are dissolved and lost forever. Only the most durable objects survive, typically stone tools and fragments of pottery, creating a frustratingly incomplete picture of a once vibrant community. The process of sea level rise itself was an agent of destruction. It was not a gentle, predictable filling of a bathtub. It was punctuated by catastrophic meltwater pulses, sudden, massive releases of water from the collapsing ice sheets. These events would have sent devastating tsunamis and violent storm surges crashing across the low-lying coastal plains, scouring the land and obliterating any settlements in their path long before the slow burial by sediments could preserve them. Yet, against all these odds, there are breakthroughs. In the Gulf of Cambay off the coast of India, sonar surveys have detected what appear to be the geometric outlines of structures and retrieved stone artifacts that suggest a settlement dating back thousands of years. Off the Yucatán Peninsula in Mexico, in the labyrinthine cave systems that were dry land during the Ice Age, divers have found the skeletal remains of early humans alongside the bones of extinct animals. Each of these finds, however controversial, proves that the evidence is down there. The pursuit of our sunken heritage is a race against the elements, a push to develop ever more sophisticated methods to locate and excavate these lost chapters. It is a quest that demands immense resources and ingenuity, but the reward is a revolution in our understanding of human history, a story written not in stone but in silt waiting on the ocean floor. These ancient stories of a world consumed by water echo from every corner of the globe. In the Epic of Gilgamesh, the god E warns the hero Utnapishtim to build a great boat because the gods plan to destroy mankind with a flood. In the Bible, Noah is given a similar divine command. The ancient Greeks told of Deucalion and his wife Pyrrha, her surviving a deluge sent by Zeus. Cultures from the Americas to China to India preserve their own versions of this cataclysmic event. The sheer universality of these myths is startling. Could they all be mere coincidence, or do they point to a shared, searing memory passed down through hundreds of generations? The geological timeline provides a compelling clue. The most dramatic and rapid rises in sea level, events that would have visibly reshaped coastlines within a single human lifetime, occurred between 14,000 and 8,000 years ago. This period perfectly overlaps with the era when these foundational myths are traditionally set. For the communities living on the fertile plains of Sundaland or the Gulf Oasis, the encroaching ocean was not a slow, invisible process. It was a tangible, terrifying reality. They would have watched their hunting grounds vanish, their freshwater springs turn brackish, and the graves of their ancestors disappear beneath the waves. This was not a single storm, but a relentless, inescapable enemy, a slow-motion apocalypse that forced a permanent, traumatic retreat. The stories born from such an experience would not be simple weather reports. They would be foundational traumas woven into the very fabric of a culture's identity, explaining how the world they knew was lost and why they had to start anew in a different land. These narratives, told and retold around campfires for millennia before being written down, would inevitably be shaped by cultural lenses, attributing the disaster to displeased gods or moral failings. The core truth, however, remains: a world was drowned and only a few escaped. While we cannot draw a direct, provable line from a specific flood myth to the sinking of Doggerland, the collective voice of these stories is too powerful to ignore. They represent a profound bridge between hard science and human experience, suggesting that our oldest and most sacred tales are not pure fantasy, but are rooted in the deepest, most dramatic environmental event our species has ever collectively faced. The evidence is not just in sonar maps and sediment cores, but in the stories we have told ourselves for thousands of years, a haunting echo from the shores of a lost world. The same rising seas that reshaped our continents also left their mark deep within us, written in the very code of our DNA. The great diasporas from places like Sundaland and the Gulf Oasis were not just cultural events, they were profound genetic bottlenecks. When a large, diverse population is fractured and forced into a rapid exodus, only a small subset of its total genetic variation makes the journey. The survivors who reached new lands carried only a fraction of the original gene pool, creating a founder effect that would define their descendants for millennia. This is why the genetic signatures of indigenous populations in the Americas and Australia show such clear evidence of having sprung from very small, isolated founding groups. Their entire genetic history was shaped by a journey across landscapes that are now entirely underwater. The isolation did not end with the migration. As the seas rose, they cut off escape routes, trapping populations on newly formed islands and peninsulas. A group isolated on a piece of high ground, once part of a vast plain, would have experienced accelerated genetic drift. In this separation, random changes in their gene frequencies, rather than natural selection, could quickly create a unique genetic identity, distinguishing them forever from their cousins on the mainland. By meticulously comparing the DNA of modern populations and, when possible, ancient skeletal remains, geneticists can trace these ancient paths. They follow the trail of unique markers as they branch and diverge, and these routes consistently point back to a common source, a coastal zone that is now submerged. The genetic story and the geological one are two independent witnesses telling the same truth. One reveals the changing stage, while the other tracks the movements of the actors upon it. This biological evidence allows us to see the ghostly outlines of entire lost populations, to understand the scale of their journeys, and to confirm that our most ancient ancestors truly did walk on lands we can no longer see. This meticulous correlation of sea level and archaeology is the first crucial step in the hunt. Scientists begin with a graph, a sea level curve, which charts the ocean's dramatic rise and fall like a patient's vital signs across millennia. This timeline is built from hard data, from the growth rings of ancient coral reefs that fossilized at specific depths, and from isotopes locked within sediment cores pulled from the ocean floor. Each point on this curve marks a moment when the shoreline was in a different place. The next step is to overlay the human story onto this geological map. Researchers take all the known archaeological sites from a region, those found safely on dry land, and plot their ages against the sea level graph. A clear pattern emerges, revealing windows of time when vast stretches of the continental shelf were not just dry, but prime real estate for human habitation. Imagine a distinctive style of stone tool, a unique hand axe found repeatedly in inland caves and dated to 10,000 years ago. The sea level curve confirms that at that exact time, a huge coastal plain was exposed for dozens of miles offshore. The logical conclusion is inescapable. Those same toolmakers almost certainly lived and worked on that now drowned plain. Their campsites are likely still out there, preserved under layers of marine sediment. This method transforms an impossibly vast search area into a targeted zone. Instead of scanning the entire seabed, marine archaeologists can focus their sonar and submersibles on the ancient river channels and lake shores that were above ground during these specific habitable windows. It is the difference between searching for a needle in a haystack and having a map that shows you exactly which part of the haystack to look in. This practice turns abstract geological history into a practical guide, a treasure map where X marks a spot that has been hidden under the waves for thousands of years. Once a promising area is identified on the sea level map, the real detective work begins. Peering through hundreds of feet of murky water requires a kind of technological X-ray vision. Archaeologists deploy a silent, non-invasive arsenal of geophysical tools to see what lies below without ever touching the seafloor. Side-scan sonar is their primary eye, a device towed behind a research vessel that paints the seabed with sound. It does not simply measure depth, it listens for the texture and shape of everything it passes over. The returning acoustic signals reveal a detailed image, a ghostly photograph of the bottom. On these screens, the past comes into startling focus. The smooth, sinuous curves of an ancient river channel snake across the display. The sharp, geometric outline of a potential structure stands out against the natural chaos. It is like discovering the footprints of a landscape perfectly preserved under the mud. But what about what lies beneath the surface? For that, they use a sub-bottom profiler. This tool sends lower frequency sound waves that penetrate the seabed itself, slicing down through the layers of accumulated sediment. The returning echoes draw a vertical cross-section, a slice of time. Scientists can clearly see the band of ancient peat, the solidified remains of a freshwater swamp, lying between layers of marine sand. they can identify the hard, reflective surface of the old soil horizon, the very ground upon which people once walked. This is the ultimate confirmation, the proof of a drowned terrestrial world. To find the traces of human activity within that world, they turn to a magnetometer. This instrument is exquisitely sensitive to the faintest distortions in the Earth's magnetic field. A concentrated cluster of stone tools, a hearth that burned for generations, or the remains of a clay kiln all create a subtle but detectable magnetic anomaly. It is the signature of a campsite, invisible to the eye but screaming its presence to the right technology. Together, these methods weave a multidimensional portrait of a lost world. Researchers are no longer just guessing. They are mapping the drowned hills and valleys, the river systems and lake shores with astonishing precision. This allows them to ask incredibly specific questions. Where would a community have built their settlement, close to fresh water but safe from floods? The data points the way. This prospecting phase is absolutely vital, transforming an impossible search into a targeted excavation. It manages the immense cost and logistical nightmare of sending divers or robots to the depths. Why spend weeks blindly sifting through mud when you can first look at the blueprints? These detailed surveys provide the crucial context, the lay of the lost land, telling archaeologists not just that people were there, but precisely where to find them. These vanished river systems were the superhighways of the ancient world. They did not merely flow across the plains, they sculpted them, carving deep valleys and depositing rich soils that created ecological hotspots of staggering abundance. Think of a river like the Sahul, a watercourse so vast it drained nearly a third of the Australian continent, flowing across the now drowned shelf into the Timor Sea. Or the Channel River, a powerful torrent formed from the Thames and the Rhine, which carved a massive valley through the heart of Doggerland. These were not just streams, they were the lifeblood of the landscape. Where these mighty rivers met the sea, they built sprawling deltas and labyrinthine estuaries. These transition zones are, even today, among the most productive environments on the planet. For ancient people, they were a permanent, all-you-can-eat buffet. The fresh water attracted herds of animals to drink. The marshes and mudflats were nurseries for countless fish and crustaceans. The skies would have been thick with migratory birds, and the riverbanks themselves offered fertile ground for edible plants and trees. This concentration of resources in one place allowed for something revolutionary, semi-permanent settlement. Communities could put down roots, their populations growing denser and more complex than those of their cousins roaming the harsh, resource-poor hinterlands. The rivers provided more than just food. Their gravel beds were the hardware stores of the Stone Age, laden with high-quality, workable stone like flint and chert. A single river valley could provide everything a society needed to thrive, from sustenance and shelter to the raw materials for its most vital technology. This is why the rising seas were so much more than a change of address. It was the systematic destruction of an entire way of life. As the saltwater advanced, it poisoned the freshwater ecosystems. The estuaries were drowned, the deltas submerged, the rich hunting grounds and fertile banks obliterated. The river valleys that had once connected communities became silent, sunken trenches, severing ancient trade and communication routes. The very economic and social foundation of these coastal societies was washed away. This profound loss, however, gives us our greatest clue. To find where these people lived, we must first find their rivers. By mapping the ghostly courses of these ancient waterways on the seafloor, archaeologists can pinpoint the most likely places for settlement. The logical spots are the same as they would be today. The river bends where the current slows, the high bluffs overlooking a confluence, the sheltered areas near the ancient estuary. The lost rivers guide us, their silent channels now pointing the way to the drowned homes of our ancestors. This relentless environmental pressure forged a new kind of human ingenuity. With their ancestral hunting grounds vanishing beneath the waves and familiar animal herds disappearing, mere adaptation was no longer enough. Survival demanded invention. The old ways of foraging and hunting were becoming unreliable, so communities began to experiment. They started to deliberately cultivate the most useful plants they knew, selecting seeds from the hardiest grasses and tending to them. This was not a sudden discovery, but a desperate, gradual shift toward controlling their food supply. At the same time, the loss of large game may have prompted the first steps toward animal domestication. Why chase scarce and dangerous prey when you could manage and protect smaller, more docile animals like goats and sheep, ensuring a steady source of meat, milk, and hides? This fundamental shift from hunting to herding and from gathering to cultivating was arguably born from crisis. The catastrophe was rewriting humanity's entire relationship with the natural world. The ocean itself became a new frontier. As rich coastal plains flooded, people could no longer just wade into the shallows to gather shellfish. They had to venture further out. This necessity spurred a revolution in maritime technology. Simple rafts gave way to more sophisticated boats capable of withstanding open water. New types of hooks, nets, and harpoons were developed to catch fish that lived in deeper, more distant waters. The very act of surviving the deluge was turning these coastal foragers into the world's first true mariners and deep-sea fishermen. And as populations were compressed into smaller territories, social life became more intense and complex. Disputes over the best remaining land, water sources, and fishing rights would have been inevitable. To prevent conflict from tearing communities apart, new social structures had to emerge. Leaders were likely chosen to mediate disputes, rules were established for resource sharing, and concepts of territory and ownership became more formalized. This forced cooperation under pressure may have planted the seeds of governance and law. The Great Floods did not just destroy a world, they built a new one in its place. The immense adversity of a changing planet, the very force that erased so much, may have been the essential crucible that forged the foundations of civilization itself. The flooded caves of the Yucatán Peninsula are portals to a vanished world. These are the cenotes, natural sinkholes leading into a labyrinth of underground passages carved from porous limestone. During the last ice age, this was not a water-filled maze but a dry, subterranean landscape. The lower sea levels had drawn down the water table, leaving these vast caverns open and air-filled. They were not just geological oddities, they were vital resources and sacred spaces for the first people to reach the Americas. Deep inside these pitch-black chambers, far from the ancient sunlight, those pioneers sought shelter, performed rituals, and sometimes met their end. The preservation within these cenotes is nothing short of miraculous. On the surface, bones, wood, and plant matter decay rapidly in the humid jungle climate. But in the flooded caves, the environment is a perfect time capsule. The water is incredibly still, with no currents to disturb the sediments. More importantly, it is anoxic, completely devoid of oxygen. This lack of oxygen halts the growth of bacteria and fungi that would normally consume organic material. The result is a kind of suspended animation. A wooden torch dropped by a hunter 10,000 years ago does not rot. It simply lies on the cave floor, waiting. The skeleton of a young woman, placed in a chamber as a burial offering, remains almost perfectly intact, her story locked in her bones. These underwater sites have yielded some of the most direct and startling evidence of early Americans. Divers, acting as underwater archaeologists, have navigated the dark, narrow tunnels to make profound discoveries. They have found the hearths of ancient campfires, their charcoal still black and ready to burn. They have recovered the remains of giant ground sloths and other extinct creatures that fell into the sinkholes. Most significantly, they have uncovered human skeletons like that of Naya, a teenage girl who lived nearly 13,000 years ago. Her nearly complete skeleton provides an invaluable genetic snapshot of these first inhabitants. These are not just scattered artifacts, they are frozen moments from a time when this entire cave system was part of a dry, living landscape far from the sea. This changes our entire approach to finding lost coastal settlements. The cenotes teach us that the evidence is not always lying plain on the open seabed. Sometimes the key is hidden in associated geological features, places that acted as natural traps and preservers. The low sea levels of the Ice Age exposed the continental shelf, creating a vast coastal plain where the Gulf of Mexico now sits. The Yucatán was inland then, and its caves were part of that broader territory. The people whose remains we find in the cenotes were almost certainly part of communities that lived and hunted on that now drowned plain. The caves are a back door, a side entrance into a world we can no longer directly access. They offer a creative and powerful solution to the central problem of underwater archaeology, showing us that by understanding the full ancient landscape, we can find its secrets even in the most unexpected places. The ocean floor holds shapes that seem to defy nature. Off the coast of Japan, the Yonaguni Monument rises from the seabed, a massive formation of clean-cut platforms and sharp, 90-degree angles that look for all the world like a submerged step pyramid. In the Gulf of Combat near India, sonar images reveal what appear to be the geometric foundations of a vast city, which many associate with the ancient mythical Dwarka, the sunken capital of the god Krishna. These discoveries ignite our sense of wonder, offering the tantalizing possibility that we have finally found the physical proof of legendary civilizations. Yet, this is where the romance of discovery collides with the rigid standards of science. The Earth is a master sculptor, and its geological toolbox is full of surprises. The immense pressures of tectonic shifts can fracture bedrock into perfectly straight lines. Persistent ocean currents can erode sandstone into flat, stepped terraces. The slow, random process of jointing in stone can create blocks that appear meticulously carved and placed. What looks to our hopeful eyes like a sunken city wall or a ceremonial plaza can often be explained by the patient, unconscious artistry of natural forces. For an underwater structure to be confirmed as human-made, archaeologists demand a higher burden of proof. They need to find artifacts in their original context, a stone tool lying on a carved step, or pottery shards nestled against a foundation. They search for telltale tool marks, the specific scars left by human hands working the stone, which are distinct from the random scouring of sand and water. They look for evidence of construction, like stones that have been quarried and transported from a distant location, or architectural designs that repeat in a way that nature never does. This scientific skepticism is not meant to dampen enthusiasm, but to protect the integrity of the search. The passionate debate between proponents and skeptics, however, serves a vital purpose. It captures the public imagination in a way that a routine sediment core never could. This fascination fuels funding for new expeditions and drives the development of even more sophisticated imaging technology. The quest to prove or debunk a Yonaguni or a Dwarka pushes the entire field of marine archaeology forward, refining its methods and sharpening its questions. Whether these specific sites are ultimately revealed to be natural or human, the hope they represent is undeniably real. They are beacons, drawing us deeper into the abyss, reminding us that the greatest prize still lies hidden, waiting for the day when our technology and our patience finally match the scale of the ocean's secrets. When the sonar screens and magnetometers reveal a target of high potential, the true test begins. This is the moment theory meets the murky, unforgiving reality of the seabed. Conducting a targeted underwater excavation is one of the most complex and demanding operations in all of archaeology. It requires a small army of specialized divers, surface support crews, and a floating laboratory of precise recording equipment. Every single action is a battle against the environment. The water is cold, visibility can drop to zero in an instant, and the crushing pressure limits dive time. A task that would take minutes on land, like brushing sediment from an object, can consume an entire dive session. To carefully peel back the layers of time, archaeologists use tools like vacuum dredges, which act like underwater vacuum cleaners, gently sucking away overlying silt and sand to expose the ancient ground surface without damaging fragile artifacts. Every square inch of the site is mapped within a three-dimensional grid system, with each artifact photographed and its exact position recorded before it is ever moved. This obsessive focus on context is what separates a simple collection of objects from a genuine archaeological story. A lone stone tool is just an interesting rock. But that same tool found lying next to a cluster of animal bones, inside the outline of a post hole from a house, and near a hearth filled with charcoal, tells a vivid story of domestic life. It reveals where someone lived, what they ate, and how they organized their space. This is why the search for features like ancient trash piles called middens is so critical. These discarded shells and bones are time capsules of daily existence. Every fragment recovered from the seabed, whether a piece of waterlogged wood from a tool or a charred seed from a meal, is a miracle of preservation. These materials survived centuries of salt water and sediment against all odds just to tell their story. Such excavations are achingly slow, incredibly expensive, and fraught with physical danger. Yet they remain the only way to gather the direct, irrefutable evidence that people not only passed through these submerged landscapes, but built homes and lives upon them. Every carefully excavated post hole, every mapped hearth, is another piece of the puzzle, slowly reassembling a world we thought was lost forever. For the first peoples of Australia and the Americas, the Great Floods are not a theory but a memory. Their oral histories, passed from elder to child across hundreds of generations, speak of a different world. Aboriginal traditions meticulously describe a time when the coastline stretched far out to sea, when you could walk to islands that are now isolated by deep water. Along the Pacific Northwest, the stories of native tribes tell of ancestral villages that were slowly consumed by the encroaching ocean, forcing their people to retreat to higher ground. These narratives are not mere legends or symbolic fables. They are the living historical archives of cultures that witnessed these events firsthand. They represent an unbroken chain of testimony, a collective memory of a lost geography that perfectly aligns with the scientific map of the drowned continental shelves. The details are too specific, the geographical descriptions too accurate to be dismissed as coincidence. This has led to a profound and necessary shift in how we search for the past. Scientists are now beginning to understand that the most important map to these sunken worlds may not be drawn with sonar, but held in the sacred stories of indigenous communities. By approaching these traditions with respect and collaboration, researchers can gain invaluable guides. An elder's story about where the freshwater springs once bubbled up, or where the old trading path met the coast, can direct a multi-million-dollar research vessel to the exact spot where a settlement likely stood. This partnership is more than just a practical strategy. It is a reconciliation of two ways of knowing, Western science provides the tools to see beneath the waves, while indigenous knowledge provides the context to understand what we are looking at. It transforms the search from a cold, technical recovery operation into a human story of loss, resilience, and an unbreakable connection to a homeland that has been physically lost for millennia. The data from a sediment core tells us when the sea rose, but the stories tell us what it felt like to watch it happen. They give a voice to the ghosts of Doggerland, Sundaland, and the Gulf Oasis, reminding us that this is not just a geological mystery, but a deeply human one. The silent, sunken plains are about to give up their secrets. We are entering a new era, a revolution in underwater discovery powered by machines that see what humans cannot. Picture fleets of autonomous underwater vehicles, or a UVS, gliding effortlessly through the dark, mapping the seabed with a clarity that was pure science fiction just a generation ago. These robotic explorers can cover vast, empty stretches of ocean floor, creating three-dimensional maps so detailed they can reveal a single, hand-sized stone tool nestled in the sediment. But the sheer volume of data they collect is immense, an overwhelming flood of information. This is where artificial intelligence steps in. Researchers are now training machine learning algorithms to scan these digital landscapes, teaching them to recognize the subtle, geometric signatures of human activity. The AI can learn to distinguish a naturally fractured rock from a deliberately flaked hand axe, or identify the circular pattern of post holes from a long-vanished hut, spotting in minutes what might take a human expert years to find. The very ground beneath the waves is becoming a new source of evidence. Scientists are developing techniques to extract microscopic traces of ancient DNA and proteins from marine sediment cores. The idea is staggering. We could one day take a core sample from the floor of the North Sea and from a single layer of silt detect the genetic signature of a human presence, the biological echoes of a campfire where people once cooked a meal, all without recovering a single artifact. As these technologies become smaller, cheaper, and more powerful, the pace of discovery will explode. We could be just a decade or two away from a complete, high-resolution map of the world's drowned Ice Age coastlines. This would not be a simple topographical chart, but a dynamic, intelligent system highlighting zones of high probability, the ancient river bends and sheltered lagoons most likely to hold the remnants of settlements. This is the key to unlocking that 20,000-year gap in our human story. The next great chapter of archaeological discovery is shifting away from the deserts and the jungles. It is moving offshore into the deep where the final pieces of our origin are waiting, illuminated not by the sun, but by the quiet, persistent glow of robotic headlights. This immense technological promise comes with a profound ethical weight. The very sites that hold the keys to our past are now caught in the crosshairs of our modern world. The seabed is no longer a quiet graveyard. It is a contested industrial zone. Heavy fishing nets dragged along the bottom, a practice known as bottom trawling, act like underwater bulldozers, scouring the seafloor and shredding any fragile remains in their path. Dredging for ports and shipping lanes can scoop up an ancient settlement and dump it as sterile spoil. The seismic blasts used in oil and gas exploration send shockwaves through the water that can crack and collapse delicate structures buried in the sediment. Even the construction of offshore wind farms, a symbol of a cleaner future, involves driving massive pillars into the seabed, potentially pulverizing the archaeological layers beneath. These activities do not just disturb a site, they annihilate it completely. A stone tool scattered by a trawl net loses all its context, becoming a meaningless rock. The outline of a house carefully mapped by sonar can be erased in a single day. These are not renewable resources. Once a submerged settlement is destroyed, that chapter of the human story is gone forever, with no hope of recovery. The urgency is real and immediate. We need a global framework of protection, similar to the international agreements that safeguard historic shipwrecks like the Titanic. National governments must enact and enforce laws that recognize these drowned landscapes as official cultural heritage sites, placing them off limits to destructive industries. This is not about halting progress, but about managing it with wisdom and foresight. The goal is a collaborative model where archaeologists work directly with industry planners. A company planning a new pipeline can fund a marine survey to map the proposed route, not as a regulatory hurdle, but as a chance to discover and digitally preserve any sites in its path. This proactive approach turns a potential conflict into a partnership for discovery. At its heart, this mission transcends the preservation of artifacts. It is about safeguarding a narrative of human resilience. These sunken settlements are the most powerful testament we have to our ancestors' ability to survive and adapt to catastrophic climate change. They faced rising seas that reshaped their entire world, and their story is a deeply relevant lesson for our own planetary future. The race is now twofold: a sprint to develop the technology to find these lost worlds, and a desperate defense to protect them from being lost a second time, this time by our own hands. Solving this ancient puzzle demands a new kind of science, one that breaks down the walls between disciplines. The true story of our drowned past cannot be found in a single dataset or a lone excavation trench. It emerges only when we weave together many different threads of evidence. Picture an archaeologist standing on the deck of a research vessel, but they are not alone. They are working beside a geologist who interprets the sonar map of a submerged river channel. A climatologist explains how shifting monsoon patterns would have affected the local vegetation. An oceanographer analyzes sediment cores to determine how quickly the seafloor was buried, and a geneticist compares DNA from ancient bones to trace the migration routes of the people who once lived there. This is not a series of separate investigations, but a single, unified quest. Each piece of data informs and verifies the others. A geological survey might pinpoint the location of an ancient freshwater spring. Pollen spores extracted from a sediment core near that spring can then reveal it was surrounded by nut-bearing trees and edible grasses. This combination of landscape and botany creates a powerful prediction, a high-probability target for an archaeological survey. It tells us precisely where to look for the campsites, the stone tools, the cooking pits of the people who would have been drawn to that very spot for its vital resources. This collaborative model transforms scattered clues into a coherent narrative. It turns a sonar blip into a potential village, and a genetic marker into an epic journey across a sunken plain. The strength of this approach lies in its convergence. When the sea level curve from the geologists, the vegetation model from the climatologists, and the artifact scatter from the archaeologists all point to the same conclusion, we can be confident we are not just seeing patterns in the noise, but reconstructing a lost reality. This is how we move from hunting for single artifacts to rebuilding entire ecosystems and the human communities that thrived within them. The fragmented story of our coastal origins is finally coming into focus, not through a single brilliant discovery, but through the patient, integrated work of many minds looking at the same lost world from different angles. The same ocean that separated these lost worlds also connects their stories into a single planetary event. We often study the flooding of Doggerland, the drowning of Sundaland, and the peopling of the Americas as separate archaeological puzzles. But they are not isolated incidents. They are all different acts in the same grand play, driven by a single cause, a warming planet and its rising seas. From the frigid Bering Strait to the warm waters of the Bass Strait, every coastline on Earth was redrawn by the same relentless process. And at every one of these frontiers, human communities faced a nearly identical set of impossible choices: retreat, adapt, or perish. The specific tools may have differed: a bone harpoon in the north, a woven net in the tropics, but the innovative spirit behind them was the same. The social pressures that forced scattered bands to coalesce into more complex societies along the shrinking coasts of Britain would have felt very familiar to the communities being squeezed together on the highlands of New Guinea. This is the powerful revelation that comes from a global view. We are not looking at a collection of random tragedies, but at a controlled experiment on a planetary scale. The environment changed in a universally consistent way, and humanity, in all its diverse cultures, responded with a strikingly consistent toolkit of survival strategies. This allows us to see past the local details and identify the universal patterns of human resilience. The story of the Great Floods is therefore one of our oldest and most fundamental narratives. It is the story of how our species, when faced with the loss of its entire world, did not simply vanish. It learned to build boats, to plant seeds, to forge new social contracts, and to journey into the complete unknown. By weaving these separate strands of evidence into a single cord, we gain something more valuable than just a revised history. We gain a deep time perspective on our own relationship with a changing climate, a reminder that our capacity for innovation was forged in the crucible of environmental catastrophe. The resilience that allowed us to survive the end of the Ice Age is the very same resilience we must call upon today. Our maps of history point to the fertile river valleys of Mesopotamia and the Indus as the sole birthplaces of civilization. But this might be a profound case of looking for lost keys only under the street lamp. The truly revolutionary developments, the first experiments in settled life and social complexity, may have occurred centuries earlier on the vast, fertile plains that are now at the bottom of the sea. These coastal zones were uniquely blessed. Their estuaries and deltas were ecological powerhouses, offering a staggering, year-round abundance of food from both land and sea. This richness did not just support life, it enabled a new way of living. Why would a community risk the uncertainties of seasonal hunting when the waters teemed with fish and the marshes were full of edible plants? This reliable surplus could have allowed for semi-permanent villages to emerge, fostering population growth and the world's first class of specialists, toolmakers, artists, and perhaps even leaders. In these stable, resource-dense environments, people would have developed the essential cultural toolkit for civilization: intricate social networks, advanced maritime technology, and sophisticated knowledge of their ecosystem. Then the floods came. The rising seas did not just displace people, they forced a massive transfer of knowledge. Uprooted communities carried this cultural software, this accumulated wisdom of settled coastal life, with them as they retreated inland. They arrived in the river valleys not as blank slates, but as refugees equipped with generations of experience. Suddenly, these different groups were compressed into smaller territories, their collective knowledge colliding and merging. The agricultural revolution, then, may not have been a sudden invention born of desperation in a new land. It could have been the logical application of old coastal skills to a new interior environment, a desperate attempt to recreate the lost food security of their drowned paradise. The first farmers, then, might not have been pioneers but survivors. This perspective transforms the traditional cradles of civilization from unique points of origin into secondary staging grounds, places where the seeds of a culture, cultivated for generations on a sunken shore, finally sprouted into the world we know. The search for these lost lands is no longer a niche pursuit. It is a quest to find the true first chapter of our collective story. Our journey across these drowned landscapes reveals a profound truth. The map of human history is fundamentally incomplete, its most formative chapters written on parchment now submerged beneath the waves. The lost continents of Sundaland and Doggerland, the fertile oasis of the Persian Gulf, and the coastal superhighways of Beringia were never marginal backwaters. They were the central arenas where humanity honed the essential skills for civilization. It was on these sunken plains that we first mastered the sea in boats, learned to manage the plants and animals around us, and forged the social contracts needed to live together in larger, more complex communities. The Great Flood was a catastrophic force, a global trauma that erased entire homelands. Yet, in a powerful paradox, this same disaster acted as a crucible. It compressed scattered populations, forced desperate innovation, and accelerated migrations that would ultimately seed the entire planet with new ideas. The evidence for this is no longer circumstantial. It converges from every direction, from the genetic trails in our DNA and the geological maps of the seafloor to the haunting, universal echo of flood myths that have persisted for thousands of years. We now stand at a unique moment, a crossroads in time. For millennia, this past was simply inaccessible, a ghost story told by the ocean. Today, our technology is finally catching up to our curiosity. With autonomous robots, artificial intelligence, and new methods to read the very silt of the seabed, we are poised on the brink of discoveries that will fundamentally rewrite the story of who we are and where we came from. The true birthplaces of civilization were concealed not by the slow dust of time, but by the relentless rise of water. Our task, our great adventure, is to bring them back into the light. Let this be an invitation to see the ocean differently, not as a barrier separating nations, but as the deepest and most silent keeper of our collective secrets. The world we lost is waiting to be found, and its recovery promises to reveal not just our past, but a deeper understanding of human resilience itself.